Hello, everybody. So I do have written out solutions to the Chapter 5 review exercises, but in case you want a little extra help figuring out how I did those review problems, how I got those solutions, I made this video to talk you through it. So, number one had multiple parts to it, a bunch of equations to solve. We have to figure out what number goes in place of x to make the equation true. And in these first six, I translated from logarithmic form to exponential form. For instance, log to the base 6 of 36 equals x in exponential form would be 6 to the x power equals 36. Once I had it written like that, I just had to think, what number can I put in place of x? 6 to what power gives me 36? Well, the answer is 2. 6 to the 2 power equals 36. 9 to the 1/2 power equals x. Well, 9 to the 1/2 power would be the same as the square root of 9. So x is the square root of 9, which is 3. X to the 3 power equals 8. So we want a number that when you raise it to the 3rd power, you get 8. Well, that number would be 2. Log of 1,000,000 equals x. Remember, when we write log without a little subscript, we mean the common log, the base 10 log. So in exponential form, that would be 10 to the x power equals 1,000,000. So the power you have to raise 10 to get 1,000,000 would be 6. The common log of x, that is the base 10 log of x equals 4, in exponential form, that would be 10 to the 4 power equals x. So x is 10 to the 4th power. 10 times 10 times 10 times 10, that's 10,000. And ln, that is log to the base e of x equals 3, in exponential form would be e to the 3 power equals x. And then my calculator tells me that e to the 3 power is approximately 20.086. Whenever the answer didn't come out exact, I've rounded it to 3 places after the decimal point. The next 3 are in exponential form, but we might be able to figure out what x is better if we translate them into logarithmic form. So here we're going the other way, from exponential to logarithmic form. 10 to the x power equals 66 would mean log to the base 10 of 66 equals x. Well, log to the base 10 is just the common log, so your calculator can give you the log of 66. It's about 1.820. Log to the base 9 of 19,683 equals x. Well, to evaluate the base 9 log on a calculator, we can use that change of base theorem. To get the base 9 log of a number, we can take the common log of that number and divide by the common log of 9. Or we can use natural logs. We can take the natural logarithm of that number and divide by the natural log of 9. Either way, the answer comes out as 4.5. So that's x. 9 to the 4.5 power does equal 19,683. And then e to the x equals 535 in logarithmic form would be log to the base e of 535 equals x. And then log to the base e, that's the common log, that's the ln. So that's the natural log, not the common, the natural log. So the ln of 535 is 6.282. The ln of e to the x plus 3, well, that's easy because ln undoes what e does. Those are inverse functions of one another. So for ln of e to the x plus 3, we can just write x plus 3. Now we've just got the equation x plus 3 equals 17. So subtract 3 on both sides, x equals 14. 9 minus 2 times ln of x equals 15. First, solve this equation to get ln of x equals something. So subtract 9 on both sides, you get negative 2 ln x equals 6. Divide both sides by negative 2, you get ln of x equals negative 3. Now to undo the ln, take e to both sides. E to the ln of x would just be x, and e to the negative 3, put that into your calculator, it comes out as, well, to the nearest thousandth, 0.050. 100 times 1.4 to the x equals 1600, or 1600. To solve this, I would first divide both sides by 100. 1600 divided by 100 is just 16. Then I would rewrite that in exponential form. X equals log to the base 1.4 of 16. And then I can use that change of base formula to evaluate on my calculator. The base 1.4 log of 16 would be the common log of 16 divided by the common log of 1.4. And that comes out to be about 8.240. It would also be possible to, when you get to this point, take logarithms of both sides, then use that property of logarithms that says that log of 1.4 to the x power would equal x times the log of 1.4. Then to go from x times something to just x, divide both sides by the something. And you get x equals the log of 16 divided by the log of 1.4. Couple warnings, things not to do that I see some people mess up on this kind of problem. Do not multiply 100 times 1.4 here. Powers come before multiplication in the order of operations. So we can't multiply the 100 times the 1.4 and then raise that whole thing to the x power. And do not divide both sides of this equation by 1.4. This is not 1.4 times x. It's 1.4 to the x power. They are very different things. If it was 1.4 times x, you just divide both sides by the 1.4. Undo multiplication with division. But it's not multiplication, it's raising a number to a power. It's exponentiation. Number 2 is just some calculator exercises. So you should know how to use your calculator to evaluate things like this. Most people don't have any trouble with this, but if you can't figure this out, or if you try this and get different numbers from what I got, make sure you figure out how to do these on your calculator. Ask me for help if you can't figure it out yourself, but should be pretty straightforward. Next thing says, use the properties of logarithms to expand the expression, sorry, I left out a space there, but ln of x squared y. What properties of logarithms are we talking about? These properties of logarithms. So one of them says that if you have a logarithm of a product of something times something else, you can break that up into the logarithm of the first thing plus the logarithm of the second thing. So this would be equal to ln of x squared plus ln of y. And then the third property says that a logarithm of something to a power is equivalent to the power times the logarithm of the something. So we can rewrite that ln of x squared as 2 times the ln of x. So the final answer is 2 times ln of x plus ln of y. Now let's use those same properties just in the other direction to condense the expression 3 times the log of x minus the log of x plus 2 to the logarithm of a single quantity. So our final answer here should just be the log of some expression. So first I can use property 3 to rewrite 3 log x as log of x to the 3 power. And then I can use property 2 to rewrite the log of something minus the log of something else as the log of the first thing divided by the second thing. So we get log of x cubed over x plus 2. Now some Some word problems. An advertising agency found that the number of units sold in is related to the amount A spent on advertising by the formula N equals 1,500 plus 300 ln A. So in that equation, the N stands for the number of units sold, and the A stands for the amount spent on advertising. First question, how many units are sold, that is, what is N, after spending $20,000 on advertising, when A is 20,000? So just put 20,000 in for A. We're calculating 1,500 plus 300 times ln of 20,000. And if you put that into your calculator correctly, it should come out to be 4,471 to the nearest whole number. Then B, how much needs to be spent, that is, what does A have to be, to sell 3,600 units, for N to be 3,600. So put 3,600 in for N and solve for A. Subtract 1,500 from both sides, then divide both sides by 300, then get the ln out of the way by undoing it with the e to the x function. E to the ln of A would just be A, and so that would be equal to e to the 7, which comes out to be about $1,096.63. So $1,096.63. If $400 is invested at 6.8% interest, compounded monthly, that is 12 times per year, how much will you have after 11 years? So remember the formulas for compound interest. And you will get to use these formulas on the test, so you don't have to memorize them, although it's great if you did. But here, how much will you have means what will A end up being? The $400 is the P. That's the amount you start with. The 6.8% is the interest rate. That's the R, but we have to put it in decimal form, so that would be 0.068 for R. 12 is the number of times per year the interest is compounded. For N, that is 12 compoundings per year, we put 12 in both places there's an N in the formula. And after 11 years, we put 11 for T. So we're calculating 400 times 1 plus 0.068 over 12 to the 12 times 11 power. Put that into your calculator and make sure you get 843.33. You do have to put the 12 times 11 inside parentheses. So it's going to look something like this on the calculator. 400 times, in parentheses, 1 plus 0.068 divided by 12, close parentheses, to the power of, in parentheses, 12 times 11, close parentheses. So I'm rounding to 2 places after the decimal point because this is supposed to represent an amount of money. So to the nearest cent, this would be $843.33. Okay, I'm going to end this video here. We have a few more of these review problems to go over, and I'll put those in a separate video.